Hi, I'm Anthony Hirica, an applications engineer at Freescale Semiconductor, and I'm here to introduce you to the TWR MCF5225X, a microcontroller module within the tower system. We'll walk through the HVAC demo, which is described in Lab 4 of the lab tutorial document, which you can find on the included DVD as well as online. The TWR MCF5225X-KIT contains the TWR MCF5225X MCU module, the TWR SCR peripheral module, 2 elevator modules, and Ethernet and USB cables. It also includes a DVD that has all the software and demos you need to get started with your own code development. Lab number 4 is an HVAC demo that uses the MQX RTOS to display HVAC information via a web server, and it can also read pages off a USB stick. It demonstrates the MQX RTCS, MFS, and USB stacks working together to provide a full software solution. Let's start by reviewing the software you'll need to install. First, install CodeWarrior for ColdFire version 7.1 and then install the 7.1.2 patch. Both of these can be found on the DVD included with your kit, or you can download the 30-day evaluation version from the web. Then install the MQX software package. This is included on the DVD, or go to our website for the latest version. Next, assemble the tower kit as described in Step 2 of Lab Tutorial 1. Plug the primary connector sides of the TWR MCF5225X module and TWR SCR module into the functional elevator board. Then connect the dummy elevator board to the other side. Plug in a USB cable into the OSBDM port on the TWR MCF5225X module, and then the Ethernet cable into this TWR SCR module. Programming and debugging are handled with the open source background debug module known as OSBDM. It only requires a simple USB cable, and this cable also supplies the power to the tower system. The first time you connect the tower system to your computer, Windows will install a driver for the debugger. Follow the prompts to automatically detect and install this driver. Now open CodeWarrior and open the HVAC web server project as described in the lab document. Close the programmer window, then select the internal flash debug build target. The IP address for the system is set to 169.254.3.3 by default and should require no setup on your computer if you have DHCP enabled. Wait a few minutes for the computer to acquire an IP address and make a connection. The computer may report limited or no connectivity, however it will still have a good connection. If you have problems connecting, set up the network manually as described in the lab document. Compile the project by pressing the F7 key or by clicking on the Make icon on the project pane toolbar. Then flash the code to the processor by clicking on Tools and then Flash Programmer in the menu bar. Click on the Load Settings button and select MCF52259 internalflash.xml and click OK. Then click Erase/Blank on the left-hand side of the programmer window and erase the flash by clicking the Erase button. Finally, click on Program Verify also on the left-hand side of the Flash Programmer window and flash the MCU by clicking on the Program button. After you're done programming the MCF5225X, close the Programmer window and click on the Debug icon on the project plane. This will start up the debugger. Then click on the green Debug icon again to begin running the application on the tower system. Open up a web browser and go to the address 169.254.3.3. The web pages that appear are programmed into the internal flash memory of the MCF5225X processor. Navigate to the HVAC control page by moving your mouse over the HVAC demo link on the left-hand side and then selecting the Change Settings link. You can also control the HVAC application by pressing the Switch 1 and Switch 3 push buttons. You can monitor the temperature change on the HVAC status web page. You can also attach a USB flash drive to the serial board to read the web pages stored on it. Copy the files in the USB Web Pages directory, which is located under the Web HVAC folder, to a USB stick. Then plug the flash stick into the board, which requires the use of a Mini B USB adapter. Then hit refresh on the browser to see a new link appear on the left-hand side. Clicking on this link will allow you to browse the web pages stored on the stick. Now let's take a look at the MQX software that enabled the previous demo. Open up the task.c file in the Web HVAC project. There are 3 tasks that will auto-start at boot up: HVAC task, shell task, and USB task, because the MQX auto-start task flag is set and they are part of the web HVAC application. Looking closer at the HVAC task, located in HVAC-task.c, we can see that the Ethernet stack is started with a call to HVAC initialize networking. Diving into that function, we can see that RTCS is configured and created, and then the web server is started, which will run as its own task. The RTCS Users Guide, located in the doc/RTCS directory, has more information on using RTCS. Going back to the HVAC task, the HVAC system is initialized, and a heartbeat task is created that blinks an LED to a signal that the system is running. Finally, the HVAC task goes into a while loop where it continuously checks for new inputs and updates the outputs accordingly. Now let's look at the USB task, which is located under the USB folder in usbtasks.c. It starts the USB host driver and then waits for an attach event. Once that event is detected, it calls the USB file system install function to create the MFS file system on top of the USB stick. That function is located in usbfile.c, where it installs the MFS and partition managers. For more information, you can view the USB host and MFS user guides located in the documentation folder in MQX. That concludes the HVAC web server lab for the TWR MCF5225X. Please explore the files on the DVD for more information on the MCF5225X and MQX, and check us out online for the latest documents and training. I also encourage you to become a member of the online Tower System community, where you can participate in forums, post videos, and find the latest Tower System information on Twitter and Facebook. Thank you.